How to make calculations for water-containing salts. What are water-containing salts? They are like this. When you see the formula of the salt followed by a certain amount of molecules of water. That amount of water can be variable, all right? Imagine you buy this salt, this cupric sulfate. If you buy the anhydrous salt, that means without any water, you would get a white powder, and the molar mass of this salt is 1 copper, 1 sulfur, and 4 oxygens. So the molar mass of this salt is 159.5 grams per mole. What if you buy the hydrated salt? There's also the hydrated sulfate with 5 molecules of water per mole of salt. That is a blue crystal or a blue powder. And how do we calculate the molar mass of this compound? To make the molar mass, you have to consider the molar mass of the salt itself plus 5 times the molar mass of water, because there are 5 moles of water here. So the entire mass is in this case 249.5 grams per mole. So we can make these relations. The molar mass of the hydrated salt contains 1 mole of salt plus 5 moles of water, or if you think about it in grams, it's the molar mass of the salt plus 90 grams of water. 90 grams is the 5 moles we have here, 5 times 18. So how do we make calculations for a solution preparation? For instance, how much hydrated salt is needed to prepare 300 milliliters of a 0.2 mole cupric sulfate solution? First, you calculate the necessary solute. You have to respect the 0.2 molar ratio, so it's 0.2 moles per liter, 1000 milliliters. And you are going to prepare 300 milliliters. So the amount of moles needed is 0.06 moles. In what mass of the hydrated salt I find this amount of moles? Let's look at this. 1 mole of the salt is in 249.5 grams of the hydrated salt. This is what I know from the beginning. But I don't need 1 mole of salt. I barely need 0.06 moles. So I would have to weigh 15 grams of the hydrated salt to contain the needed sulfate. What if I have to prepare a solution that has to be 2% of iron, and the only salt I have to prepare the solution is a hydrated chloride, ferric chloride? In this case, the ratio that I have to respect is this: 2 grams of iron per 100 milliliters of solution. Let's see that this 2 is in a percentage. It's not molarity, it's not in 1000, it is in 100 milliliters. But I'm going to prepare 450 milliliters. So how much iron do I need is 9 grams. Now, the molar mass of this salt, if you sum up 1 iron, 3 chlorines, and 6 waters, you would get 270.3 grams. So this whole mass of the hydrated salt contains how many moles of iron? Only 1. It's only 1 iron in here. And iron is 55.8 grams per mole. So this is the mass of iron contained in 1 mole of the hydrated salt. If I need 9 grams of iron, I will need this amount of hydrated salt and then dissolve it in 450 milliliters of water. Thanks for watching, and you can like and comment and subscribe.